Okay. All right. So today, ladies and gentlemen, what my goal is to cover three sections: 1.2, and well, no, 1116 and 21. There we go. All right. So what is 1.1 addressing here? Well, 1.1 is entitled Positive and Negative Numbers. Oh, Liz, I mean, if you have like any noise or distraction in your background that could disturb other students online here, just put yourself on mute, okay? That would be very courteous to everybody else. If I ever have any noise or in my background, I will mute myself quickly too. All right, ladies and gentlemen, let's look at positive and negative numbers. This is the number line here. Okay, I like to put 0 on the number line because to the right of 0, we have what are called positive numbers, correct? Now I'm going to lay out the first several positive numbers here. And of course, this keeps going to the right. How far to the right does this keep going? I got 5, I got 6, 7, 8. How far to the right does this go? Well, that arrow indicates that
Continue.
It goes forever to the right. Do you agree? Okay. Now, 1 unit to the left of 0 on the number line is the number called -1. 2 units to the left of 0 on the number line is the number called -2. 3 units to the left of 0 on the number line is -3. 4 units to the left of 0 on the number line is -4, et cetera, et cetera. And you agree that this goes to the left forever also? This number line goes to the left forever. Okay.
Yes.
All right, the way it works on the number line is this. Like when we go to the right on the number line, you're always encountering larger numbers. The further you go to the right on the number line, you always move towards larger numbers. If you go to the left on the number line, you're always encountering smaller numbers. There is no exception to this rule, okay? All right. Now, ladies and gentlemen, -4, do you agree, is, we say, less than -1. Is that true? -4 is less than -1? Or is smaller than -1? Because -4 is what? Further to the left of -1, isn't it?
Yes.
So -4, we say, is less than -1.
Yes.
We have a mathematical symbol to represent that -4 is less than -1 instead of writing these words out here. And you know what that symbol is? It's called an inequality symbol. And this is how we would represent this fact. We would say -4 is less than -1. This symbol here, ladies and gentlemen, is called an inequality symbol. Inequality. So we would say -4 is less than -1. Or synonymously, what's that also saying? It's saying -1 is what? Greater than -4. Isn't that true? Now, you're probably wondering, how do I remember which way this inequality symbol should point? Well, one way to remember it is that it must always point to the smaller of the two numbers being compared. So -4, we say, is smaller than -1. Or you know what? There's an even cornier way of remembering this, but if it works, use it. You could think of this as being like an alligator's mouth. And the alligator is really hungry and hasn't eaten for several days. So the alligator wants to eat the bigger of the two things. You see that? So -1 is bigger than -4. How does that sound? Alligator's mouth always opens to the bigger of the two numbers being compared. All righty. If it works, use it. Now, -100, I have a question. When you compare -100 to -78, is -100 less than or greater than -78? Think about it, ladies and gentlemen. Which number would we encounter first as we move from right to left on this number line? We would run into what number first, -78 or -100?
-78.
Yeah, -78 would be encountered first. Then we'd have to go further to the left to run into -100. Because of that, -100 we say is what? Is less than. Do you agree? So -100 we say is less than -78. And we would write that using our inequality symbol as such. Negative 100 is less than negative 78. Is this making sense so far? Do you agree that 0 is greater than negative 2? 0 is greater than negative 2. Why is 0 greater than negative 2? Anybody? Why is 0 greater than negative 2? Sophia? I might pick on people from time to time. Don't mind me. Sophia, why do you think 0 is greater than negative 2?
Because negative 2 is below 0.
Okay, yeah, it's below 0, or we say it's further to the left on the number line. Do you agree? So negative 2 is smaller than or less than 0, which means that 0, since 0 is to the right of negative 2 on the number line, 0 is greater than negative 2. And you know how we're going to represent that symbolically? We would put the 0 here, and then I would have to say 0 is greater than negative 2 by having my inequality point to the negative 2. Everybody see that there? This is saying 0 is greater than negative 2. Remember, think of this as being like an alligator's mouth. It always wants to eat the bigger of the two numbers. Do you agree? So 0 is bigger than negative 2. Think of it that way. All right. All right. How about 30 compared to negative 30, ladies and gentlemen? What would I put in between these numbers as far as words are concerned to illustrate which number is larger or smaller? What would I say? 30 is what to negative 30?
Greater than.
Yes, 30 we would say is greater than negative 30, because positive 30 is way over here to the right. Do you agree? Negative 30 is way over here to the left. So negative 30 is a lot further to the left of 30 on the number line. And so obviously 30 is greater than negative 30, or negative 30 is less than what? 30. So synonymously, you could say negative 30 is less than, okay, less than 30. If you have it worded this way, 30 greater than negative 30, you would say 30 is greater than negative 30. Inequality points to the negative 30. But if you label this way, which is saying the same thing, negative 30 is less than 30, you would say negative 30, and the inequality points to the what? The negative 30. Is this making sense what direction the inequality points here? Anybody confused so far, or we understand what's going on so far here? Okay. Now, the next thing, Liz, that we're going to run into is something called the absolute value of a number. Absolute value of a number. Okay, and there's symbols that represent the absolute value function in mathematics. It's a set of vertical bars. So if you're looking at this expression in mathematics, you know how we read what we're looking at here? This is to be read as the absolute value of negative what? Negative 4? So that's how you read this expression, the absolute value of negative 4. So these vertical bars represent the absolute value function in mathematics. Now, what is the absolute value of negative 4 really equal to? Well, when you take the absolute value of a number, it basically just reports how many units away from 0 the number is. And so, ladies and gentlemen, negative 4 is how many units away from 0, albeit to the left of 0. Negative 4 is what? 1, 2, 3, 4 units to the left of 0. Do you agree? Negative 4. So you know what the absolute value of negative 4 simplifies to, or is equivalent to? We would say it's equivalent to positive 4. So the absolute value of negative 4 is just 4. Now, we don't even have to put the plus sign in front of the 4. If we omit the plus sign, it's understood that it's still a positive 4. If you don't see a sign in front of a number, it's understood to be a positive number, okay? So the absolute value of negative 4 is 4. That's all there is to it. What's the absolute value of negative 15? What do you think? The absolute value of negative 15. Denisha, what do you think, Denisha? Absolute value of negative 15 is equal to?
15.
15. That's correct. All right. Lydia, what do you think the absolute value of 120 is?
Negative 120?
No, it's how many units is 120 away from zero on the number line?
120.
Just
From
120
0 to-
units. Yep. So the absolute
Okay,
value of
I get it
120 is
now.
just 120. Okay. You know, so that's the way it works. That's the way the absolute value works. When you take the absolute value of a number, it basically just reports the positive of that number, does it not? That's what's going on here. And it doesn't matter what number you put in there. You could even put a decimal in there. The absolute value of 17 and 35 hundredths. You know what the absolute value of 17 and 35 hundredths is going to be? 17 and 35 hundredths. You see that there? Okay. So whenever you take the absolute value of a number, it just reports the positive of that number. What do you think the absolute value of 0 is?
1?
0.
No, zero is 0 units away from itself. Do you agree? So it's just 0. The absolute value of 0 is 0. Yeah. All right. So that's all there is to absolute value. And again, it doesn't matter, you know, if I take the absolute value of negative 7 3/4, this mixed number, what do you think the absolute value of negative 7 3/4 is? What do you
7
think?
3/4.
7 3/4.
That's right. It's just 7 3/4. Everybody understand how the absolute value function works? That's all there is to absolute value. Okay. No more mystery than that. All right. What I want you to do here, ladies and gentlemen, we're going to do this together as a class. Let's place the correct inequality in between these numbers here. We're going to place the correct inequality between these numbers, 7 and negative 5. So to make this a true statement, how would I have my inequality oriented? What number does it point towards? Which number is greater? Which one's smaller?
It'll point to negative 5.
Okay, so negative 5 is, we say what? Less than 7, or 7 is greater than negative 5? Is that correct?
Yes.
Okay, see how we did that there? All right. How would we do this? I'm going to make this a negative 2. How would we have the inequality pointing in between these two numbers?
Negative 2 is greater than negative 13.
You are correct. Is greater than negative 13. Negative 2 is greater than negative 13. All right. Negative 14 compared to 0. How do we put our inequality between these numbers here?
Negative 14 is less than 0.
Yeah, negative 14 is less than 0. Okay. All right. How about the absolute value of negative 12 compared to negative 7? Which one's greater? Which one's smaller? The absolute value of negative 12, that's what this means. The absolute value of negative 12 compared to negative 7.
Negative 7 is greater.
Now, what is the absolute value of negative 12?
12.
That'd
So,
be 12, right? So it's really like comparing 12 and negative 7.
so 12 is greater.
We would say 12 is what? Greater than negative 7, right?
Yep.
Yep. So that's how you'd have to orient your inequality symbol to have a true statement there. All right. How about the absolute value of negative 2 versus the absolute value of negative 7? Which one's greater? Which one's smaller?
The absolute value of 7.
Okay.
It is great.
What's the absolute value of negative 2? What is this equal to?
2.
2. And this is equal to
7.
7. Okay. Now what's bigger?
7.
7.
So 7 we say is what? Greater than 2, or 2 is what? Less than 7. Agree? So therefore, yeah, you would have to have your inequality looking like that. Is this making sense how we're orienting our inequality so that these are true numeric statements here? Okay. All right. Any questions about that there? This is a well-known fact in mathematics. Every number has an opposite. Every number has an opposite. Okay, here are examples of opposites. 7 and -7 are opposites. -25 and +25 are opposites. Okay, -3/4 is the opposite of +3/4. Those are opposites. -17.3 is the opposite of +17.3. 0 is a funny number. 0 is its own opposite. The opposite of 0 is 0. By the way, ladies and gentlemen, 0 is neither positive or negative. Isn't that weird? 0 is just 0. Okay, so 0 is the strangest number on the number line. It is its own opposite. So what's the opposite of -547?
Positive 547.
Positive 547. That's the opposite. So every number on the number line, and there's an infinite number of numbers on the number line, infinite number of decimals and fractions, positive whole numbers, negative whole numbers. Every number on the number line has an opposite. Every single one. Any questions with what opposites are? All right. Moving right along then. Got that there? All right. Now, what if I want you to simplify this numeric expression? Now, to simplify a numeric expression, what does it mean to simplify something? Well, to simplify it means to rewrite it as an equivalent but simpler expression. So, ladies and gentlemen, if I look at this, if I'm confronted with this expression here, how do I interpret what I'm even looking at here? How do I even read what I'm looking at? Well, you know how you would read this here? You see that negative sign in front of this -3? You would read that as the word opposite. Think of it as the word opposite. So we're trying to take the opposite of what? -3. Opposite of -3. And what is the opposite of -3? What's that real? Yeah, it's really equivalent to +3. Isn't that true? So this would simplify to +3. The opposite of a -3 is a +3. Now I want you to contrast that with this, where I put the -3 inside absolute value symbols now. And what if I want you to simplify this expression? Well, we got to be careful here. This still is interpreted as the word opposite. But now we want to take the opposite of the absolute value of -3. What is the absolute value of -3? What is the absolute value of -3?
3.
Just +3, correct? Just +3. But then we have to take the opposite of 3. And what's the opposite of 3?
Negative.
Yeah. So as it turns out, this simplifies to really -3. First, we took the absolute value of -3, which is what? 3, agree?
Correct.
But then I had to take the what? The opposite of that. What's the opposite of 3?
Negative.
-3. Everybody see how that worked there? So there is a big difference between absolute value symbols and parentheses here. Notice this evaluated or simplified to 3. This simplified to -3. So be a little bit careful with your absolute value versus your parentheses. We understand the difference there? What just happened? Okay. Here's an interesting question. Is -20 closer to -40 or to 10? What do you think the answer to this question is? You know, if you sketch a quick number line here, you can put your -40 out here to the left, put your -20 maybe a little bit further to the right of -40, and put your 10 way up here, and maybe put your 0 in here somewhere. What number is -20 closer to? -40 or +10? What would be your guess?
+10.
Okay, now how many number or units or numbers are in between -20 and 10? I mean, what's the distance between -20 and 10? Well, to go from -20 just to 0 is 20 units. Do you agree?
Mm-hmm.
That's 20 units. And then we got to go to 0, from 0 to what? 10. That's 10 more units. So what's the total distance between -20 and 10? The total distance is 20 plus 10, or what, 30 units away. Do you agree?
Correct.
How many units is -40 and -20? How many units away or away are
20.
these numbers? 20 units, right? So it looks like -20 is closer to what?
-40.
Yeah, it looks like it's closer to -40 than it is to what, 10? Everybody see that there? Yeah.
Mm-hmm.
So therefore, it looks like -20 is closer to -40. -40. Okay. So maybe by drawing it out on a number line, that'll help you to better understand. You know what I'm saying? What number is closer to? Just kind of by sketching it out on a number line. Okay. All right. Now, I just wanted to kind of like begin breaking ground a little bit with our calculator here, just to kind of like get us off the ground, moving a little bit, ladies and gentlemen, but don't worry too much about it. You know, if you don't have the calculator today, it's no big deal. First of all, are there any questions about anything on this page here? Okay.
No.
All right.
Nope. All set.
Let's try a couple problems here. Now, if I wanted to do like -2 subtract 5, okay? Now, let me just show you on your calculator how we would do this problem here. -2 subtract 5, because that's how we read what we're looking at. Do you agree? -2 subtract 5 or -2 minus 5? How would we do that on our calculator? Well, depending, it doesn't matter which calculator you have, the 30 or 34, or even you said you had a different model. Should work the same way. Anyways, ladies and gentlemen, preceding the 2 is what sign here? This is a negative sign, correct?
Mm-hmm.
And this is the what sign? This is the minus sign. Anybody see the difference there? Negative sign and minus sign. Okay. So to type this in on my calculator here, to have my calculator help me do this, I would have to type in -2 subtract 5. So see at the bottom of my keyboard here, I have my negative button here. Just to the left of my enter button, I see the little negative button here. I would have to hit that button first and then type in the 2. That qualifies 2 as being a -2. Everybody see how I did that again? I hit my negative button first and then my 2. Now on your calculator that you have, do you see a negative button on your machine?
Yes, I do.
Okay.
Yes, I do.
So it should work. So -2, and then we hit our minus button because it was -2 minus 5. Do you agree? Don't hit your negative button again. Hit your subtraction button. -2 minus 5. Notice there's a difference in length on this calculator between a negative sign and a what? A minus sign. The minus sign is a little longer than the negative sign. You see that there? All right. When you hit enter, enter means equals. You should get negative what?
7.
-7. So -2 subtract 5 is -7. Everybody see how we did that there?
Mm-hmm.
Okay. All right. And that would work, the same on the TI-34. Let's try this one. If you have -10 subtract a -7. Now look at this here. How would we simplify or negotiate this? This one gave us -7. Well, this is interpreted as a what? Negative sign?
Yes.
This is interpreted as a minus sign, and
Minus.
this is interpreted as a what? A negative sign,
Negative.
right? Okay,
Yes.
so let's type this in our calculator. We'll type in -10 subtract or minus a -7. Let's see if we can do that on our calculator. So clear our screen. And we type in -10, so negative button first, and then type in 10. negative 10, subtract or minus a negative 7. Now, you could enclose the negative 7 inside parentheses. This is your open parenthesis here. And then I'll type in negative 7. And then you have your closed parenthesis. Everybody see the open and closed parenthesis here? Open parentheses above the 8 key, closed parentheses above the 9 key. Do we see that there? Okay. So that would be okay. You don't have to use parentheses around a negative 7. That's not critical. You know, if you choose not to use parentheses around a negative 7, it'll still work. Negative 10 minus a negative 7. You'll still get the same answer of negative 3. Everybody see that there? Negative 3. Okay. All right, so this should evaluate to a negative 3. Now you're probably wondering, wow, what if you don't have a calculator? How would you negotiate these things? Well, ladies and gentlemen, the way it works is subtraction is the same thing as adding the opposite. So when you take some number A and subtract off some other number B, just to keep this argument general here, it's the same thing as changing subtraction to addition and adding the opposite of the number being subtracted off. So like when you look at this negative 2 minus 5 here, negative 2 subtract 5, I can rewrite this expression equivalently as negative 2, and then I can change my subtraction to addition. But then I have to add the opposite of 5. What's the opposite of 5? The opposite of 5.
Negative 5.
Yeah, so it'd be negative 5. All right, now, the way it works with sign numbers is a negative added to a negative is always a negative, and we always add the numbers together. So negative plus a negative is always a negative, and we add. So a negative 2 added to a negative 5 is going to be a negative what? What's 2 plus 5? Negative 7?
Yeah.
Okay. Let's negotiate this one manually. Negative 10 subtract a negative 7 is equivalent to as if I say negative 10, change subtraction to what? Addition. But then I have to add the opposite of negative 7. What's the opposite of negative 7?
Positive 7.
Positive 7. And now, ladies and gentlemen, I'm adding a negative and a positive together. We have a rule for that. A negative added to a positive, or if you add a positive to a negative. In other words, when you add numbers together that have opposite signs, the rule is this. Step number 1 of this rule is you take the difference between the numbers. Take difference. You don't add them together, you take the difference between them. And the second step of this rule says you attach the sign to your answer that's in front of your larger of your 2 numbers. I just like to say attach larger sign. So a negative 10 added to a positive 7. What's the difference of 10 and 7? What's the difference of 10 and 7? Difference. Don't add these together. Don't call it 17. No, what's the difference of 10 and 7?
3.
3. Now, which number is bigger, 10 or 7?
10.
10, and it is negative. So your answer in this case would be what? Negative. Everybody see how that worked there? So if you don't have a calculator, ladies and gentlemen, you can still negotiate these problems manually. But obviously, we are able to use our calculators in this class. So this really should be no sweat once we get our calculator. Do you agree?
Mm-hmm.
That's the beautiful thing about Math 072 is you can use a calculator to deal with this. You don't have to learn these special rules here. Isn't that neat?
Yes.
It can really save a lot of time and headache, I'll tell you. Okay. All right. Now, we can also multiply and divide sign numbers on our calculator. Like if I take a negative 2 and multiply it by a negative 5. By the way, in between the parentheses here, it's understood it's multiplication. Understood. Negative 2 times a negative 5. That's how we read this expression. We're multiplying a negative 2 by a negative 5. Well, if you don't have a calculator, ladies and gentlemen, a negative times a negative times a negative always gives you a positive, or a negative divided by a negative also always gives you a positive. If you mix the signs and multiply or divide, you always get a negative. In other words, a negative times a positive or a positive times a negative always give you a a negative. That's true for division too. A negative divided by a positive or a positive divided by a negative. In both cases, you get a negative. So if you don't have a calculator, what's a negative times a negative going to be?
Positive.
It will be a positive. And what's 2 times
10.
5? Yeah, positive 10. It'll be positive 10. But if you have a calculator, we can use our calculator. How would you type that in? Well, it's pretty simple. Pretty simple. All you do is clear your screen. You can use parentheses if you want. Open parenthesis, -2, closed parenthesis. You don't even have to put times in between the parentheses. You can just hit another open parenthesis. Your calculator understands that it's multiplication in between the parentheses. Understood. And it says type in -5, closed parenthesis. Your calculator will take care of business now. Hit enter, and you get positive 10. Everybody see that there? We just multiply 2 negative numbers together. So you can have a lot of fun on this calculator. Now, if I was to take like -40 and divide it by, let's say, a positive 5, what's a negative divided by a positive? Do you remember the rule I just laid out? I know I went over it kind of fast, but a negative divided by a positive is always a what? Always a negative, correct?
Always negative.
So if you take a -40 and divide it by a positive 5, we should get negative what?
-8.
-8. See how this is working here? Okay. So I just wanted to show you some basic manipulations on your calculator here, ladies and gentlemen, just to kind of like get us maybe pointed in the right direction with the machine there. All righty.
Okay.
Okay. Okay. So. All right, that's essentially is section 1.1. All right, so we got our feet wet with working with negative numbers and positive numbers. Where are negative numbers actually used in the real world? Anybody got any ideas or give us some examples?
The temperature.
Air temperature. Yeah, we definitely experienced that the last couple of days.
Oh.
I mean, I think we got down to like 8 below zero. -8 degrees Fahrenheit, you know, a couple of days here on my thermometer I was reading at nighttime. And so temperatures is an area where negative numbers are obviously used. Any other areas where negative numbers have any relevance out there?
Account balances.
Mm-hmm. Yeah, if you look at your checking account and you see this, your heart's going to skip a couple of beats. Do you agree? That's no good, all right? Yeah, I mean, never want to have negative amounts in your accounts. So negative numbers can indicate a deficit in an account, all right? Negative numbers are also used to indicate topographic relief. For instance, if you have an airplane that's above sea level is normally designated as the 0-foot level. It's called sea level. So if you have a airplane that's 5,000 feet above sea level, we would say its altitude is plus 5,000 feet. Do you agree? As opposed to if we have a submarine that is 2,000 feet below sea level, we would say its depth is negative 2,000 feet. Does that make sense there? So negative and positive numbers can help us relate to some sort of a reference level when it comes to altitudes, correct?
Mm-hmm.
Right. Negative and positive numbers can also be used for what are called vectors. For instance, if I designate the north direction as the positive direction and the south direction as the negative direction, if I say I get in my car and I drive negative 20 miles per hour, that indicates, ladies and gentlemen, that I'm really driving 20 miles at a speed of 20 miles per hour in what direction? In the south direction. Do you agree?
Yeah.
You see that? So negative signs in front of like speeds can indicate direction. They're called vectors. All righty. So negative signs do have a lot of relevance in our everyday lives, whether we realize it or not. All right. Now, there's going to be times in this course when we start working with what are called letters or variables, ladies and gentlemen. And it's really the concept of a variable or a letter that separates a course from basic math from that of algebra and beyond. All right. And so in section 1.6, we're going to embark on simplifying what are called algebraic expressions. Simplifying algebraic expressions. And in algebraic expressions, you run into what are called variables. And the most typical variables that are used in early algebra are like X or Y or Z or A, B, N. These are typical variables that are used, okay? Now, notice our X looks like the traditional multiplication symbol. And so like when we say 2 times 3 back in basic math, in algebra, we have to change our symbol for multiplication. Oftentimes we use the dot operator, okay? Because the dot operator does not enable us to be confused with the traditional multiplication symbol, which now could take on the meaning of a variable X now. Do you agree?
Oh, okay.
So we have to go to the dot operator to avoid confusion in algebra for multiplication. All right. Okay, so these concepts of variables here, and to help us simplify variable expressions or algebraic expressions, ladies and gentlemen, we're going to tap into a couple of properties of real numbers. And the first property is called the associative property of real numbers. And that's basically saying that if you multiply like 3 numbers together, the order in which you multiply the numbers together does not matter. Okay. In other words, if I'm multiplying 3 numbers together in general, number A, B, and C together, if I want to multiply all 3 of these numbers together, it doesn't matter if I multiply A times B first and then multiply that product by C, or if I choose to multiply numbers B and C together first and then multiply that product by A. You should get the same answer in both cases. This illustrates what's called the associative property of real numbers. The associative property involves 3 numbers and it involves parentheses. Specifically, it involves shifting parentheses. So do you agree on the left side of this expression here, the parentheses indicate that I would multiply A and B together first. But on the right side, the precedence has shifted in saying that I would multiply B and C together first and then multiply that by A. This illustrates the associative property. In other words, let's look at an example. If I gave ourselves 2 times 3 times 4, if I did 2 times 3 first, what would I get? What's 2 times 3?
6.
What's 6 times 4?
24.
24. But what if, ladies and gentlemen, I wanted to do 3 times 4 first? What's 3 times 4? 12?
Oh, sorry.
Well,
What's 2 times 12?
24.
24. Do you agree these are equal to each other?
mm-hmm.
Isn't that true? That's what the associative property is illustrating here. When you're multiplying 3 factors together or 3 numbers together, it doesn't matter what order you multiply them together. You'll get the same product either way. Okay, that's what that's illustrating. So that's what that's illustrating. Okay, now why did I show you that property? Well, I'm going to show you why we looked at that property now, that associative property, because now, ladies and gentlemen, we're going to start to simplify algebraic expressions. And algebraic expressions are expressions that contain variables. So if I have this expression here, and how do we even read what we're looking at here? This is called an algebraic expression. This is known as an algebraic expression. And we would read this as 8 times 9 what? Times X. Do you agree? Everybody see that there? 8 times 9 times X.
8.
Now, when you multiply 9 times x, the best you can do is say that the product is 9x, because we don't know exactly what number, x has been assigned to. Okay. But in order to simplify this variable or algebraic expression, we can use the associative property. Instead of multiplying the 9 and the x together first, could I not shift my parentheses and multiply the 8 and the 9 together first?
Yes.
And then multiply that by what? The x? Can I not do that using my associative property I just showed you? But now we can do this. What's 8 times 9?
72.
72. And what's 72 times x? We just say 72x. Everybody understand how we just simplified that algebraic expression by just shifting our parentheses, just employing what's called the associative property, enabling us to multiply the 8 and the 9 together first and then multiply that by x. Everybody see what happened there? And this would be our answer. This is the simplification of 8 times quantity, 9 times x. That was pretty simple, wasn't it? That wasn't too bad.
No.
That's your answer for that problem. All right, that's called simplified. Let's try another one like that. Let's try to simplify this one here. And like I said, you can use your calculator to help you with the multiplications and to take the sting out of things. All right, let's try to take -2 times 7 times a. -2 times 7 times a. Now, how am I going to simplify this? Well, I'm going to shift my parentheses and multiply so that I can multiply the -2 and the 7 first. So I'm going to put parentheses around the -2 and the 7 first. And then I'll have the a outside the parentheses. That's illustrating the associative property here to here. See that there? Now you can use your calculator, ladies. What's a -2 times a +7? What's a negative times a positive? A negative times a positive is always a what?
Negative.
It will be a negative. You are correct. And so -2 multiplied by a +7 would be a
-14.
-14 times a, just -14a. We have simplified that algebraic or variable expression. Do we see how we're doing these problems here? And again, you can use your calculator to help you with the actual multiplications of your numbers. Okay. All right, let's try maybe another one here. How about -2 multiplied by a -5y?
So we shift it to -2 times -5.
Yes, we'll have -2 times a -5 here. Notice that when my multiplication, I elevate this little negative sign so it doesn't look like -2 subtract 5. It's -2 times a -5 times a y. What's a negative times a negative?
A positive.
Always a positive. So -2 multiplied by -5 would be a +10. And 10 times y is 10y. Okay. Is this making sense how we're simplifying algebraic expressions here?
Yes.
Yes.
Now, ladies and gentlemen, there's also an associative property of addition. Associative property of addition works the same way. Involves 3 numbers and involves parentheses and shifting your parentheses. So if I have a plus b plus c, if I'm adding 3 numbers together, I could first add a and b together first and then add that sum to c. Or I could shift my parentheses and I could add b and c together first and then add that sum to a. Do you think that the left would be equal to the right side? Do you think that would be the case? I don't think it would matter what order we add 3 numbers together. Do you agree? So you get the same answer, right? In all cases?
Yeah.
That's the associative property of addition. That's always true. So if I have 2 plus 3 plus 5, add 2 and 3 together first, I'll have 5 plus 5, which is 10. Or what if I choose to add the 3 and the 5 together first? 3 plus 5 is 8. I'll have 2 plus 8, but I'll also get what? 10. Do you agree?
Mm-hmm.
We have equivalence there? That illustrates the associative property of addition. So we've seen the associative property of multiplication, now of addition.
Okay.
That will help us to simplify yet more algebraic or variable expressions. So like if I have 9 plus quantity 6 plus x, how would I simplify this algebraic expression right there? Well, you can't really add 6 and x together because as we're going to find out, they're not really considered to be similar terms. But ladies and gentlemen, I can shift my parentheses and I can place the parentheses around a 9 and a what? The 9 and a 6. Do you agree? Associative property of addition says I can do that.
Yes.
Still equivalent. Now what's 9 plus 6?
15.
So we have
14.
15. Well, 15 on a good day. So 15 plus so 15 plus x would be the simplification of 9 plus 6 plus x there. Does that make sense how we use the associative property of addition to simplify that algebraic expression? All right. Try another one here. 4x plus 3 plus 27. Let's see if we can simplify this algebraic expression by employing the associative property of addition. And we should be able to do that just by doing what? By shifting our parentheses and adding 3 and 27 together first, all right? Now what's 3 plus 27?
30.
30. So 4x plus what? 30. Now, we cannot add 4 and 30 together here because these are not considered to be what are called similar terms, because the 30 does not have an x attached to it like the 4 does. So we would have to leave our answer like that. That makes sense there? That's called simplified. That's it. You cannot go any further than that. So don't add the 4 and a 30 together and call it 34x. That's the best you can do. Leave it as 4x plus 30. Do you see how that's working there? All right. Then we run into an extremely important property in algebra. It's called the distributive property. Used all the time. And let me use a concrete example to illustrate the distributive property before we go to variables. If I have 2 times quantity 3 plus 5, if I want to evaluate or simplify this numeric expression, the order of operations in mathematics would have me doing what's inside parentheses first. Do you agree? So what's 3 plus 5?
8.
And therefore I'll have 2 times 8. And 2 times 8 gives me what? 16? Well, ladies and gentlemen, there's a property in mathematics, specifically algebra, called a distributive property that enables me to get the same answer of 16, but by doing things a little differently. Here's what I can do. Here's what I could have done. Instead of adding the 3 and the 5 together first and multiplying by 2, I could have taken this factor of 2 outside the parentheses and I could have multiplied it into both these terms inside the parentheses first. So I could take the 2 times the 3 plus, just bring the plus sign over. And then I could also take the 2 and multiply it by the 5. 2 times 5. Everybody see that there? 2 times 3, 2 times 3, plus 2 times 5. Now what's 2 times 3?
6.
What's 2 times 5?
10.
What's 6 plus 10?
16.
Get the same answer, don't we? So this illustrates, ladies and gentlemen, what is called the distributive property. And notice when we distributed as 2 inside the parentheses, we remove the parentheses. The parentheses are removed, aren't they? They disappear. And so, ladies and gentlemen, this is a very important property called the distributive property. It says basically when you got a number times the sum of 2 numbers inside parentheses, you can distribute this number A into both these terms inside parentheses via multiplication. So I can take the A times the B plus, and then I can also multiply the A times the C. This is illustrating what's called the distributive property, used all the time in algebra. That is also true if we have subtraction. In other words, if I have A times some number B minus some number inside parentheses, it works the same way. I could take this number A and multiply it by the B, and then I'll say minus A times C. Both of these illustrate a very important property called the distributive property. So that's a valid property that can be used when simplifying algebraic or variable expressions, called the distributive property. Everybody see how that property is working there?
Mhm.
It's kind of like this one number A gets distributed or spread around among all the things inside the parentheses. Do you agree? That's what it means to distribute. It means to what? Take one of something and what? Spread it around everybody. Do you agree? It's kind of like COVID. Do you agree? It's being what? Distributed right now, unfortunately. COVID is being distributed big time. Okay. Maybe not a good example. Maybe I shouldn't have used that one. All right. If I had a stack of papers and I passed one paper out to everybody in a classroom, do you agree I distributed the stack of papers to everybody? Distributed them, right? Passed them all out. Okay. That's kind of like what's going on. Okay, so where are we going to use this distributive property as far as variable or algebraic expressions are concerned? Well, let's show you. So let's try to simplify some algebraic expressions using our distributive property. Using our distributive property. Okay, so let's take this. 7 times quantity x plus 5. We want to simplify this variable or algebraic expression by employing the distributive property. So how do you think that's going to work here? Well, I'm going to take the 7 and multiply it by the what?
5. With the X.
X. Yeah, these arrows are a good visual cue. Please use arrows too.
Okay.
So 7 multiplied by x, we say is just what? 7x?
Yeah.
What sign do I put here? Plus or minus?
Plus.
We got a plus sign. So put the plus sign. Then we're going to take 7 and multiply it by what?
35.
By the 5. 7 gets multiplied by the 5. Hence, we're going to have 7x plus what's 7 times 5?
35.
And you got your answer. Everybody see how we simplified that algebraic expression by using our distributive property. And notice when we distributed a 7 inside the parentheses, we removed the what? We removed the parentheses. Did not the parentheses disappear after distributing? They're gone, aren't they? That's always true when you distribute. You always remove parentheses. Let's try another one. How about 8 times 5x minus y? Let's try to simplify this variable or algebraic expression by using our distributive property. So what does that mean we're going to do? Well, that means I'll take the 8 and multiply it by the what?
5.
The 5x.
5x.
And then what sign do I put here? Plus or minus?
Minus.
We got a minus sign. And then we got to take the 8 and multiply it by the y?
The y.
Yep. Now 8 times 5x, what do you think 8 multiplied by 5x is going to simplify to?
Be 40x.
40x. Minus just what? 8y.
8y.
And that's it. You cannot subtract 8 from 40 because these are not, we say, similar or like terms in algebra. 40x and 8y are just as different to each other as like 40 Canadian geese are to like 8 kangaroos. Do you agree?
Mm-hmm.
No relationship. All right. So you cannot subtract the 8 from the 40. These are not similar terms or like terms. You must stop the problem right there. That's called simplifying. Making sense how we're employing the distributive property to simplifying algebraic expressions here. Okay. Let's see here. Where are we? The clock here. Yeah, we're fighting the clock. we burned a lot of time going over the syllabus and schedule. Do you agree? That's what's making this session difficult to cover the material we have to cover. That's why I'm not very fond of first days, ladies and gentlemen, because it burns a lot of valuable time. All right. Now, what are similar terms? I've been kind of throwing that, throwing those words out here loosely. I think we need to formally define what similar terms are. Similar terms in algebra, ladies and gentlemen, are terms with the same variables. Terms that have the same variables are called similar terms. Let me give you some examples of some similar terms. Some examples would be like 7x and 9x. Those are called similar terms because they're variable. They both have the variable of x attached to them, don't they? Those are called similar terms. Negative 5y versus 28y. Those are called similar terms. They both have y's attached to them. Negative 7a and positive a. By the way, when you see just a variable, you don't see any number in front of the variable, it's understood to be 1. 1, okay? So a is understood to be 1a. Understood. 1 times a is the same thing as a or 1a. Understood, okay? All right. When negative w compared to 160w, these are similar terms because they both have w's in them. You see that? The variables are the same. By the way, negative w is understood to really be what? Really understood to be what number in front of w?
-1.
Yeah, it's like a -1 times w or a -1w. Understood. Okay? Understood. These are all similar terms there. Okay? All similar terms. Technically, any two real numbers are similar terms. I know this seems weird, but like 7 and -14, these are similar terms. Think of them as being similar terms because they both don't have any variable attached to them. That's why they're similar terms. Maybe think of it that way, okay? All right. So, what's the big deal about having similar terms or not? Well, I'll tell you the big deal because here's why. What if I wanted you to simplify this algebraic expression? If I gave you 8x and to that I wanted you to add 5x. Are these similar terms, 8x and 5x?
Yes.
They are similar terms. And to add these together, we can use our distributive property kind of like in reverse. So, ladies and gentlemen, I can represent this as really 8 plus 5 of these what? X's. Everybody see how I rewrote this? Now, what's 8 plus 5? Eight plus 5 on a good day is what, 13?
Oh.
So 8x plus 5x, these similar terms we say combine or simplify to give us what, 13x?
Yes.
We have just simplified this algebraic expression down to 13x by combining these similar terms. Okay. Think of it this way in real life. If you have 8 Canadian geese on a pond and 5 more Canadian geese come to join the 8 Canadian geese, now you have how many Canadian geese? 13 of them? Isn't that true? You see that? Similar birds, do you agree? 5 Canadian geese added to 8 Canadian geese give you 13 Canadian geese. If you have 8 Canadian geese added to, let's say, 5 duck-billed platypuses, you cannot add these together now. Do you agree? They're not the same type of animal. They're not similar animals. Think of it that way, okay? Okay. You can only combine similar terms in algebra. Terms that are not similar, you cannot actually combine them. All right. Let's try another one here. How about 8a added to a? Well, what number's in front of a? I don't see a number.
It'd be 1.
Yeah, it's really understood to be 1a. So 8a plus a is really understood to be 8a plus 1a. Understood. So what's 8a plus 1a?
It'd be 9a.
Yeah, it's going to be 8 plus 1 of those a's, or it's going to be 9a. 9a. We have just, again, combined similar terms. Okay, we've simplified this algebraic expression by combining similar terms. And that works for negatives, too. if you got negative 7n minus 5n, don't matter if you got positives or negatives. These are similar terms. They need to be combined. So therefore, to combine them, we would really say that we got negative 7 subtract 5 of these what n's. Agree? Now, what's negative 7 minus 5? And that's where you could turn it over to your calculator now, correct?
Be
Negative
negative
7.
12.
Yeah, and as it turns out, it would be negative 12 of these n's. Everybody see how we're simplifying algebraic expressions by combining similar terms? By combining similar terms. All right, let's see, 211. Son of a gun. Yeah, I was supposed to cover section 2.1 also. There is no way. There is no way I want to get to 2.1. And you know what? I don't want to rush through 2.1. Here's why. Because it involves fractions. And fractions bog us down. Do you agree? So I don't want to rush through fractions. So I guess I'm throwing up the white flag here, ladies and gentlemen, that I'm just not going to have enough time to do that. So what I'm going to do is I'll give you classwork number 1, and you can turn this into me by midnight tonight. We'll call this classwork 1. Today is January 11th. Please put that at the top of your paper there. And then the subject line, when you email this to me, you would say, of course, what? Math 072.
072.
And then after that, you could maybe say, you know, classwork, you know, maybe classwork January 11th. You know, maybe you could put this in your subject line. That'd be awesome because it helps me to understand what the message is, pertains to classwork January 11th. But you, at bare minimum, you always have to have this math 072. Don't forget that. Okay. What you put after that's optional, but at least have math 072. All right. Anyways, here's a couple of problems I want you to do. Problem number 1, I would like you to try to simplify negative 5 times 20x. Try to simplify that algebraic expression. Number 2, I would like you to try to simplify this one. 11 plus 2 plus 9x. Number 3, I want you to try to simplify this one. Negative 19y minus 54y. And one more. Number 4, try to simplify this. 9 times 2x minus 6. And what property are you going to use on the last one?
Distributive.
Distributive property. Okay, go ahead and do those problems. I'll give you a couple minutes and we'll check things out. We'll call that classwork number 1.
Okay.
Okay, anybody need more time on these? All right, anybody want to contribute your answer for number one? -5 times 20x. What did we get?
Negative 100x.
Okay, so that'd be equal to -100x. Number two, when you simplify 11 plus quantity 2 plus 9x, what does this simplify to?
13 plus 9x.
13 plus 9x. You are correct. Number three, -19y minus 54y is equal to?
Negative 63y.
Okay, let's see here. So -19 added to -54. I think would be more.
Negative
73. Negative 73.
It'd be -73y. Correct. There you go. All right. How about this last one? Right. What do you think this last one might be?
18x minus 36.
Yep. 9 times 2x is 18x. Minus sign. 9 multiplied by 6 at the end. 9 times 6 is 54.
Oh, okay. I clearly need to.
Okay,
It's because I don't have my calculator. No, I'm just kidding.
So you are really in need of that machine, huh? I see.
I was rushing and then I set it down. I should have been paying more attention.
And the faster that illustrates a very important point. The faster we work through a math problem, the greater chance there is for mishap or error. It happens all the time. So yeah, you don't want to race through your problems. Yeah.
So that I can learn that.
Yeah. So like any future quizzes or exams, try not to race through the problems, okay? Because you're going to make a lot of errors and mistakes. So just try to, slow down, have a little bit of patience. I'm not saying take 10 minutes on a problem. I'm not saying that. But I'm saying just, you want to have a little bit of patience so you stay off the silly mistakes, okay? Because those little mistakes will nickel and dime us to death, won't they? If we're not careful. So we got to be careful. All right. So if you can, email this to me by midnight tonight, ladies and gentlemen, we'll call that classwork number 1 for the day. Unfortunately, I just don't have any more time. I'm out of time. So I'm just going to have to cover 2.1, which is an important section when we meet in 2 days. But I don't want to rush through fractions. Okay?
Okay.
All righty. So if there's no other questions or anything, I'll let you go. Have a great day, and hopefully I'll see you on Thursday.
Do you want us to take a picture and email it, or you want us to just type in the answer?
Yeah, I'm going to leave that up to you as to how you get these to me. You can take a picture of it if you want. You can, if you have a scanner, you can scan it. Okay. If you want to take a picture, with your phone, as long as you're able to upload it and email it to me, that'd be fine. All righty.
Okay.
Just try to make sure that the picture is legible, though. You know what I'm saying? That I could, we can make it out. Okay, it's not blurry or anything, because that's awful when it's like that. All righty.
Okay.
All right. Any other questions or anything? All righty. I'll let you go. Okay.
Awesome.
I don't know if I will. Let's see here. I might start posting some of the textbook homework for you. You can get started on it any time, but obviously it's not going to be due till February, what was it, 10th or something, 21 or something? Whatever the syllabus said, right?
I just put it away, but I think it was the first one was
by February 10th midnight, right?
Mine says February 3rd. Wait.
Homework 1 is due by February 10th midnight. So any of the problems that I assigned tonight on Canvas will not be due till what? February 10th midnight.
Okay.
Okay? All right. Have a good day.
Thank you. You too.